Now I will only take this to fully understand the diagram. So on the metal sphere, we have three types of forces acting on it. First is the tension, which is the strain. Secondly is the gravitational force, and this is called the electric force. Now, it is stated that the two spheres are given the same electric charge, so we know that like and like charges repel from each other. That's why it's going to the left. Now, since the tension involves an angle, we can solve this by using trigonometry, by drawing arrows. Since the x component is opposite to the 5 degrees angles, we'll use t sine phi. Since the y component is adjacent to the 5 degrees angles, we can use t cos phi. And now we can just remove this here, as you only need to solve this. Now, it is stated that the masses are of equilibrium, therefore the sum of the x and also the y component must be equal to 0. So first we need to know that the sum of the x components equals to 0. There are two types of x components here, which is the t sine phi, which is positive t sine phi going to the right, and also the negative electric charge, because it is going to the left. Move that here, you'll get this expression. Now we can't solve this yet because we don't know what's the t. And then next we'll find for the y component, the sum of the y component equals to 0. And also there are two types of y components acting here. The first one is the t cos phi, and also negative minus the mg, because it is going to downwards, and you move that here. You need to isolate the t, you get this. From here you can substitute this t to this equation, and you will get mg over cos phi times sine phi equals to Fe. Now we know that according to trigonometry, sine over cos is tangent, so you can just use that. Mg tan phi equals to electric charge. Now we know that the electric Fe, the formula is given, which is Ke times Q1 Q2 over R squared. So firstly we need to find the distance between these two ball of spheres, these two mass of spheres. So in order to find that, we can just draw a right angle triangle here, and since this side is opposite to the angle, we can just label it as the opposite, and this side is the hypotenuse. We can just write it as L. So to find sine angle, it is opposite over hypotenuse. So to find this, the opposite, we can just move that here. We get L sine theta equals to the opposite. Now this only applies to this one. We need to find for this side plus this side. Therefore, to find R here, we need to plus it. So L sine theta plus L sine theta, you get 2L sine theta. Now we can just substitute that to the equation here, and also you can just simplify the equation to this. And now you can use this equation and move it to here. And now we need to find the magnitude of the charge, which is Q, and you just need to move all of this to this side, and you'll get this equation. Now just substitute all of the information given here in the question into it. 2 times 0.3 L, because here it is given in centimeters, we need it in meters. Sine 5 square, and then this one is 20 exponent negative 3. The mass should be in kg, therefore you need to remember that. And also gravitational is 9.8, then 5 over the constant Ke, which is 8.9 exponent 9, and you'll get your answer approximately 7.2 exponent negative 9 coulomb. Thank you.